right, if you were absent today, this is the first lesson of Unit 5, Expressions. Now, before we get into the packet, I just want to kind of explain what an expression is. So you can see here on the top, here's an ice cream cone, an upside-down ice cream cone. And in each row of the ice cream cone is an expression. And an expression is any combination of numbers and operations. So you can see here in the first row, there are 1, 2, 3, 4, 5 numbers, 1, 2, 3, 4 different operations. So this is an example of an expression. And what you can see here on the ice cream cone is that the person who created this did what's called evaluating the expression. They, one step at a time, they used what's called order of operations to find the value of the expression. So again, each row except for this last row one is an expression. Even this one right here is an expression because it's numbers and operations. So anytime you see numbers and operations, that can be called an expression. And today, what we're going to focus on is this part of the expression. This is called an exponent. You may have seen these before in 5th grade when you were doing powers of 10. But this is an exponent here, and we're going to take a closer look at that today to be able to evaluate them or find the value of them. Okay, so we're going to turn, well, actually, if you turn to the first page, you can see there's a lot of vocab in this unit. I'm not going to zoom out here. So page 2, there's 9 words. Page 3, these are 9 somewhat probably new words to you. And then on page 4, there's 4 more words. So that's 22 words that, again, you don't necessarily have to memorize the definitions of them, but through the unit, we're going to come to learn these words. If you're ever stuck on a word or you're not sure what it means, you can, of course, look at the front pages of the packet. All right, so we're on page 5 here, and we're going to be talking today about powers and exponents. So whenever you have a number that is multiplied by itself many times, often it's easier to write it using an exponent. So for example, we have 10 times 10 equals 10 to the second power. Another way to say that, there's a special name for that. We can call that 10 squared. So whenever it's to the second power, we can call that squared. So we're going to label the parts of this expression here. This 10 and this 10, these are both called factors. And a factor is a number that you would use to multiply to get to another number. So in this case, 10 times 10, you're multiplying to get another number. Both of them are factors. And what's key here is that both of the factors are the same number. So if this was 7 times 10, we couldn't write it using an exponent. We can only use exponents when we're multiplying the same exact number by itself, either more than once, sometimes several times. So we can write 10 times 10 using an exponent here. So 10 squared means 10 times 10. This 10 here in the exponent is called a base. That's the number being multiplied. The 2 is called the exponent. The 2 represents how many times we're multiplying the 10. So for example, if it was 10 to the third power, that means we're multiplying the number 10 by itself 3 times. 10 times 10 times 10. Okay, so there's another example of how we can use an exponent. It almost is like simplifying it. Like if you're going to multiply 10 3 times, it's a bit easier to write it using an exponent than to actually write it out as 10 times 10 times 10. So that's why exponents can be useful. They can take this longer expression, this longer string of numbers, and condense it down. Now, the only thing is, if this was like 10 times 10 times 6, we couldn't write 10 to the third because there would only be 2 10s. So it has to be the same number multiplied by itself. All right, so it's this first one here says write 6 times 6 times 6 times 6 using an exponent. Okay, so we're gonna write what's called a power. You're gonna hear me say like power or exponent. Those kind of mean the same thing. So the base here, the number that's being multiplied is 6. So that's gonna be our base. That's the bigger number, the larger number. Okay. The exponent is going to be how many times we multiplied 6, and that's going to be 4. So we'd call this 6 to the 4th power, or 6 to the 4th. And that means 6 times 6 times 6. Now that has a lot of value. 6 times 6 is 36. Then you have to multiply that by 6 and then that by 6. So these numbers get really big really quick. It says, write 4 times 4 times 4. Now we can use an exponent because we're multiplying the same number a few times. The base is going to be 4. That's how many times. That's the number we're multiplying. The exponent is going to be 3 because that's the number of times we're multiplying it. 4 times 4 times 4, which would be 64. So again, these numbers get pretty big pretty quickly. All right, this next one here, 7 times 7 times 7 times 7. That means the base is 7. That's the number being multiplied, and we're multiplying it 1, 2, 3, 4 times. 7 to the 4th. Now again, that's a pretty big number. 7 times 7 is 49. Then to multiply that again by 7 would be about, I think it would be 343, and then you'd have to multiply by that by 7. So that's going to be the 2000. So again, these numbers get real big real quick. All right. The last one in this little chart here is 9 times 9 times 9 times 9 times 9 times 9 times 9. All right, so we know the base is 9. Now, it's really important that we get the exponent right because even if it's 1 less, like if we said this, well, this is, let's see what it is first, then I'll give that example. 1, 2, 3, 4, 5, 6, 7. There are 7 9s being multiplied. If we were off by 1, if we wrote 9 to the 6 instead, 9 to the 6 is 9 times less than 9 to the 7. So it's a big difference. So you want to make sure that you write the exact number because that will change the value quite a bit. All right, so now we're going to do something slightly different. We're going to kind of do the opposite. We're going to find products using the exponents. So it says write 5 squared as a product of the same factor, then find its value. Let's do it. So 5 squared, that's the same thing as the base is 5, so that's the number we're multiplying, and we're multiplying it twice, so it'd be 5 times 5, and 5 times 5 is 25. Not too bad, right? All right, let's check this one out. This one is a decimal, and that's okay. The base can be a decimal. It could also be a fraction. 1.5, or 1 5/10 to the 3rd power. So I'm going to just write that out. And that's the same thing as saying, well, the base is 1.5, so we're going to multiply that 3 times. 1.5 times 1.5 times 1.5. Now, we might have to do that off to the side here, because I'm not sure what that is necessarily in my head, but it's not going to be that big because this is only 1.5, and it's not a really big number to begin with. So what we can do is multiply 1.5 by 1.5. Okay, 0, it's going to be 5 and 1. So you got 2 and 2500ths. That's only 1.5 times 1.5. Now we have to multiply that number by 1.5 as well. This is good review, by the way. Multiplying by decimals. Good review. Great review. All right. And this will get us the answer. All right, 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. 5 times 2 is 10, plus 1 is 11. Okay, put the 0 there, placeholder 0. Okay, 1 times 5 is 5. 1 times 2 is 2. 1 times 2 is 2. Now, I mentioned before that these numbers can get really big really quick. This one, not so much because it's so close to 1. You're multiplying by a number that's so close to 1, it's not really going to grow that much. So we're going to move the decimal point 3 times. 1, 2, 3. Now, if this was 15 cubed, or 15 to the 3rd power, the number would be quite big. It would be 3,375. But this is only 3 and 375 thousandths. Okay, that would be the answer, or the product of that expression. All right, let's try this one here, and this one's not too bad actually. This is 1/2 cubed. So again, 1/2 is the base. That's the number being multiplied. And I know you see these parentheses. That the parentheses is there just to show you're multiplying the whole fraction by itself, not just the 1. Okay, so we're doing 1/2 times 1/2 times 1/2. All right, well, what's 1 times 1 times 1? Well, 1 times 1 is 1 times 1, that's 1. So this one isn't too bad, as it may seem. 2 times 2 is 4 times 2 is 8. 1/8, that would be it. So notice that 1/8 is less than 1/2. And what's happening is when you multiply a fraction by a fraction, it actually decreases in value. So we wind up with a fraction that's even less than what we started with. So sometimes exponents can get really, really small really quick, as opposed to really big really quick. All right, let's try a little more on the back. All right, so this one, these are kind of the same as what we're doing on the front. We're going to write each power as a product of the same factor and then find the value. So 10 to the 5th power, okay, that would be 10 times 10 times 10 times 10. And I'm going to show you a little trick here that you can do, okay? You're doing something like this. What I like to do is use what's called a squiggle. So I'm going to do only one of these at a time. And as we go, you'll see like we're doing simpler problems to get the eventual answer here. Well, I'm going to do 10 times 10 first. So I'm going to squiggle that. 10 times 10 is 100. And then I'm going to bring down the other 10s we didn't use yet. 100 times 10 is 1,000. Then I'm going to bring down the other 10s we didn't work with yet. This 1,000 times 10 is 10,000. Then I'm going to bring down that last 10 we didn't work with yet. Now this one is not going to fit in the box necessarily, so I apologize. Whoops. 10,000 times 10 is going to be 100,000. So there's actually a trick for tens. This only works for tens. So if you're using tens, the exponent will tell you how many zeros the number is going to have. So it's 10 to the 5th. There's going to be 1 with 1, 2, 3, 4, 5 zeros after it. So that's another trick you can use just for tens. That's a special tens trick for exponents. Okay? All right. Again, if you want to try these on your own, you can. But you can do them with me as well. So 2 1/10 to squared means 2 1/10 times itself 2 1/10. Okay, so to get that, we might have to do the work off to the side. It should be around 4, a little bit more than 4, because 2 times 2 is 4, and of course. So we'll see. We'll have to do a little work off to the side here. 1 times 1 is 1. 1 times 2 is 2. Placeholder 0. 2 times 1 is 2. 2 times 2 is 4. So you get 1 here, 1, 2. You get 4 and 41 hundredths. So again, a little bit more than 4, not really that much more than 4 though. Okay. All right, this last one again. This one's actually the easiest one of the bunch. 1/4 squared. That means 1/4 times 1/4. 1/4 times 1/4. That one's pretty easy. 1 times 1 is 1. 4 times 4, 16. And that's it, 1/16. So again, it's less than what we started with because it's a fraction. All right, so let's look at a couple word problems here. It says, the zoo has an aquarium that holds 7 to the 4th power gallons of water. About how many gallons of water does the aquarium hold? Well, to find the value, we need to find, or to find how many gallons, we need to find the value of 7 to the 4th power. And we know that 7 to the 4th power is 7 times 7 times 7 times 7. So I'm going to use my squiggles here, believe it or not. I'm going to use my squiggles. I'm going to do this one first. 7 times 7 is 49 times 7 times 7. Now, I would try this one next, 49 times 7. Well, 50 times 7 is 350. So 49 times 7 is 7 less than 350, which would be 343 times 7. This one we might have to do off to the side, which is okay. So this one is our last step here. So we're evaluating the expression. We're seeing what's the value of the entire exponent. We're going to do it one step at a time. Whoop, lights went off. Okay, so to find the value, we need to multiply 7 by 343. All right, so 7 times 3 is 21. 7 times 4 is 28, plus 2 is 30. And 7 times 3 is 21, plus 3 is 24. So the answer, these are all equal to each other, is 2,401 gallons. Okay. That seems like quite a bit of gallons. All right. Michigan has more than 10 to the fourth inland lakes. Find the value of 10 to the fourth. Well, 10 to the fourth, there's a trick to the tens, remember. It's 10 times 10 times 10. Now, you could do the trick, certainly, but you can also practice the squiggles, doing one step at a time. 10 times 10 is 100. Bring down the other 10s we didn't work with yet. 100 times 10 is 1,000. Bring down the other 10 we didn't work with yet. And then 1,000 times 10 would be 10,000. And again, that would be 1 with 4 zeros. So there's the tens trick you could have used. 10,000 lakes. Nice. That's a lot of lakes. All right. So this is a interesting problem. It says one boy has a very interesting allowance. The first week he gets $2. The week after, his allowance doubles. His allowance doubles the week after that, and so on. How much money will this boy have earned after 6 weeks? Write an expression using exponents, then find its value. All right, so the first week he gets $2. That's week 1. So I'm just going to put a week 1 there. Okay, then it says each week his allowance doubles. So that means the next week it doubles. That's week 2. And then the next week it doubles. That's week 3. And after 6 weeks, we'll see after 6 weeks. This is week 4. This is week 5. And this is week 6. Okay. All right. So I'm going to show you another way to find this more easily, because these numbers are a little bit easier to work with. What you could do is do these squiggles in groups. Okay. Actually, you know what? I'm just going to do the regular squiggle way. Let's do the regular squiggles. 2 times 2 is 4. Bring down the other squiggles. So we'll see how much he's made after 6 weeks. 4 times 2 is 8. Times 2 times 2 times 2. 8 times 2 is 16. Times 2 times 2. 16 times 2 would be 32. Times 2. And 32 times 2, $64. That's not bad. So if this continues, $64. Actually, that's what he's earned this after on week 6. That's what he gets. So you'd have to actually add these all up. At week 1, he'd get $2. Week 2, he'd get 4. Week 3, he'd get 8. Week 4, he'd get 16. Week 5, he'd get 32. So you actually have to add those up to get how much money. He would actually earn about over $100. But on week 6, he gets $64. Period. Okay? And it says, actually, we forgot, write an expression using exponents, then find it. So what would the expression be? Well, 2 times 2 times 2 times 2 times 2 times 2 would be 2 to the 6th. Okay, so that would have to be part of the answer, because it did say to write it using exponents. So that would be part of the answer there. All right, we're going to do one more thing real quick, and we're going to talk about special exponents. These are exponents we're going to see a lot this year, so I wanted to emphasize them. Okay, I was using these words before, but I was using the words squared and cubed, right? So squares have two dimensions. They have length and width. And when you have a square, the length and the width are the same. So if the length here was 10 and the width here was 10, you can use an exponent to find the area. 10 times 10 would be 100. This square is made of 100 little squares. Okay? We call anything to the second power a square. Right? So that's called a square. Now, a cube has three dimensions, 1, 2, 3. That's why when you see a 3, we call that cube, because to find the volume of a cube has all sides of the same length, same as a square, but it has three dimensions, length, width, and height. So because there are three dimensions, we call any number to the third power a cubed number. All right? So we're going to be dealing with squares and cubes a lot, so we're going to focus on these right now. So these are called the perfect squares. Okay, they go on forever, but they wouldn't just stop at 10. But we're going to stop at 10. So the exponent is 1. For all these is 2. That's called a square, because a square has two dimensions, length and width. And when you have a square, each side is the same length. So you're multiplying the same number by itself to get the area. All right, so 1 squared is 1 times 1, which is, of course, 1. And you can go ahead and complete this chart if you can kind of see where this is going. 2 squared is 2 times 2, which is 4. Now, these numbers here that we're getting are called square numbers because we can get them using a squared exponent. 1, 4. The next one is 3 times 3, which would be 9. 4 squared, okay, means 4 times 4. That's 4 squared, which is 16. So again, 16 is a square number. 5 squared, again, you can try this on your own. 5 squared is 5 times 5, which is 25. 6 squared is 6 times 6, which is 36. So all of these numbers, 1, 4, 9, 16, you can get them using a square, so these are called square numbers. 7 times 7, 49. 8 squared means 8 times 8. My third grade teacher she helped us remember this one because these are like two snowmen. She showed a picture once of two snowmen celebrating their 64th birthday. So I'll always remember that. Thank you, Mrs. Abel. All right, 9 squared is going to be 9 times 9, 80, which is 81. Again, these are all square numbers. And 10 squared is 10 times 10, which is 100. Perfect. All right, the last thing we're going to look at today are called the cubed numbers, the perfect cubes. So cubes are when the exponent is to the third power. We're just going to do a couple here, not too many. So 1 cubed means 1 times 1 times 1. Well, 1 to any power is just 1, because when you multiply 1 by itself, no matter how many times, the answer is always 1. So 1 is a cubed number. 2 cubed is 2 times 2 times 2. Well, 2 times 2 is 4, times 2 would be 8. So 8 is a cubed number, because you can get to it using 2 cubed. 3 cubed means 3 times 3 times 3. Well, 3 times 3 is 9, times 3, 9 times 3 is 27. Another cube, nice. 4 cubed, 4 times 4 times 4. Well, 4 times 4 is 16, okay? And then 16 times 4, 6 times 4 is 24. 4 times 1 is 4, plus 2 is 6. Would be 64. So it's neat because, I think it's neat. 64 is both a square, 8 times 8, and a cube number, 4 times 4 times 4. So that's kind of nice. Good for 64. All right, 5 to the third would be 5 cubed. 5 times 5 times 5. 5 times 5 is 25. That's like a quarter. And 5 quarters is 125. Last one, 10 cubed. 10 times 10 times 10. That's a 10, not a 16. That's a 10. All right, so we can use the tens trick, which is just 1 with 3 zeros, or we can just think about it. 10 times 10 is 100. 100 times 10 is 1,000, or 1 with 3 zeros, as we had said before. All right, gang, so that's a little work with exponents. We're going to be using this unit in expressions, and we just wanted to get some practice in it today, and we'll have some more practice later. All right, have a great day. If you have any questions, let me know. If not, I will see you soon. Bye-bye.